electrostatic discharge, otherwise known as ESD, is dangerous for electronics. Too much of an electric shock sent to an electric board or a piece of hardware can fry the electronics and make it unusable. In industry where the electronics being handled can cost thousands of dollars, extensive protection measures must be taken against ESD to protect equipment and products.
With the surge of 3D printing, 3D printed parts have become a staple in aiding in parts manufacturing and with assisting with electronics. Regular PLA, a common material used in 3D printing, is not rated as ESD safe. While there are ESD safe PLA on the market, they tend to be triple the price of regular PLA.
This experiment seeks to determine if using an ESD spray will be effective in making regular PLA print ESD safe. To be ESD safe, the surface resistance must be measured to be within 10 to the 6 ohms to 10 to the 10 ohms. If proven successful, companies can apply this method to make the manufacturing process with electronics more affordable.
For this experiment, we will be addressing the uncertainty in different elements associated with one equation. Our general equation will measure the surface resistance of the PLA printed boxes and how the ESD spray can make the samples ESD safe. The elements that will be changing in the equation are resistance and surface area. After conducting our test, we will use the uncertainty propagation equation to calculate the uncertainty associated with each element.
Before we conduct the experiment, we need to measure a couple things. The surface resistance, the area of the samples.
The area of the samples is measured using a slide caliper that has a range of 0 to 8.231 inches and has precision of 5,000th of an inch. The surface resistance is measured using an ESD surface resistance meter that has a range of 100 ohms to 1 tera ohms and has a precision of half a decade. The measurement of the spray is neglected due to weighing less than 1 gram.
A total of 4 different areas are tested in this proof of concept. Every sample is printed at once, so there is a mitigation of differences in quality and print settings during the print process. During the spray sequence, the parts are kept apart from one another to prevent contamination from a spray intended for another part.
The experiment goes as follows. Samples are printed and then physical dimensions and surface resistance are measured. The samples are then laid out, each sprayed with a single coating, left to sit for 30 seconds, and then the surface resistance is measured. There will be a difference in the surface resistance between the non-sprayed and the sprayed measurements.
When conducting the spray sequence, safety glasses are worn as protection.
Our first cycle of testing is concluded and we're able to analyze our results. Something of note, the resistance values of the sprayed samples are within an ESD safe range, whereas before being sprayed, the values are not in an ESD safe range.
For future testing, more samples of the 4 areas will be printed and more area variations will be printed as well. Another added factor of experimentation will be testing the longevity of the spray on the parts to determine if the spray method can be a long-term solution.